Good morning, PyCon UK. As you can probably tell from all the faff I've just committed getting my slides up here, it is the year of Linux on the desktop. I am really happy to be here, and I'm really honored to be speaking on the stage as a keynote speaker. It's my first keynote ever, so I'm a little bit nervous. Plus, I can't see my speaker notes, but we'll get through. I'm going to start by quickly introducing myself. My name is Knowler, and you can find me pretty much all the time on Twitter at Knowler. I am a web developer who lives in beautiful green Zurich, and I do write Python. Mostly I have experience doing Django and CCAN. It's an open data framework. But I also write a lot of PHP, some Go, and a little bit of JavaScript. Slowly getting over my fear of JavaScript. It was mostly unfounded. Yep, my pronouns are they, them, their, or anything else non-gendered. And my company that I work for in Zurich is called Leap AG, and they sponsored me and gave me the time to get here, so I'd just like to preliminarily thank them.
Probably typing.
Introduction. This talk is called Unsafe at Any Speed. And I am going to tell you in a second why I came up with this title. Actually, I think Daniele suggested it, but I jumped onto it wholeheartedly because it really fit what I wanted to say. But first, there's a really brief detour. This is the title that my troll brain really wanted to give this talk about bad defaults. I have had this song, Bad Romance, stuck in my head for the last 2.5 months, and now all of PyCon UK does as well, so it's fair, I think. But Unsafe at Any Speed. This is a book that was written back in 1965. It's the first book that really propelled Ralph Nader to prominence. Yeah, the same Ralph Nader who ran for president in 2000. At the time, he was becoming a consumer advocate, and Unsafe at Any Speed is a book about the dangerous excesses, I guess you could say, of the American automobile industry. In this book, Ralph Nader took 8 chapters, each focusing on a different aspect, where the American car industry was disregarding the safety of passengers, the safety of drivers, the safety of pedestrians, and the protection of the environment for no real reason other than to cut costs that they did not need to cut. This is probably the most famous example from the book. This is a first-generation Chevrolet Corvair, the sporty little Corvair, as it was called. And this one's even a red convertible, so, really sporty here. The Chevrolet Corvair, apart from some other design innovations, was most notable for having what's known as a rear swing axle. And I learned a little bit about this while I was researching this talk, but I'm going to give you some details. I won't go into super detail about this because I'm really not an auto mechanic. What is a swing axle? You can see it here. These are diagrams from Unsafe at Any Speed, and they are from the rear of the car. You can see in slide 1, image 1, that the Chevrolet Corvair, instead of having what they call a live axle, one bar that goes right across the back connecting both cars, has 2 axles that meet in the middle and are jointed. Number 1 is the car in normal loading. And number 2 is the car making a normal, moderate right turn. So you can see, oh yeah, I forgot to say, the reason for the swing axle, its purported benefit, is so that the car can respond more easily to the terrain it's driving over. If you have like a live axle, just one bar across the middle, if the right wheel kind of comes up because of the camber or it hits a bump, the left wheel is also affected. So with the swing axle, you can respond more and you don't have this interaction. However, as you can see in slide 2, the car takes a right corner and the joints of the right wheel also kind of responds. You see the wheel changes its angle. And at the arrow, you can see that the left wheel also increases its angle to the car. This is fine. We're just taking a right corner. This is fine. However, if the pressures in the tires are wrong, or if you're taking a really sharp right turn, we now get something more like picture 3. You can see the angle on the left axle is really increasing quite a lot. And if you go beyond the limits of what the car can do, which is based on tire pressure is a big one, also speed and loading, then you can possibly get something like picture 4. We call this tuck under, and as you see, the left wheel simply tucks under. The wheel can then buckle, the axle can just shoot up straight into the engine block, the car can spin out and flip over, and any passengers and drivers in this car are going to be really cross about Chevrolet's engineering principles. Chevrolet knew this was a problem with the Corvair. For an extra price, although still at cost, a customer buying a new Chevrolet Corvair could get an add-on kit including a front anti-roll bar and some other things I don't remember because they were all quite mechanical. I had this in my speaker notes. So you could buy an extra add-on to the car when it was being manufactured for you to stop tuck under happening. But Chevrolet never advertised this. You had to be knowledgeable to know that this was a risk and to know that it was a risk you wanted to prevent. The average consumer of this car would just buy the car, hopefully monitor the tire pressures fastidiously, and otherwise be at risk for a really nasty accident. Chevrolet didn't want to put this kit on the car as standard because it would have been expensive. And they didn't advertise that you could add it later on because that would have been bad publicity. Oh, why are you selling this fix? That must mean there's a problem. Is there a problem with the car? And in this talk, coming back a bit to computer software, which is why most of us are here, I guess, this is the kind of problem I want to focus on. I want to look at cases like the Chevrolet Corvair, where the right thing to do is non-obvious, and the obvious thing to do is bad. I'm going to look at a few examples, both from Python and in other areas, and I'm going to sort of discuss why I think these default situations occurred, what we can do about them, and what we as developers can do when we write new tools or new libraries to prevent issues to our users from setting the wrong defaults. Yep. Quick disclaimer, defaults aren't bad, obviously, but I want to say it, bad defaults are bad. If no software or library came with default settings, we would just spend all of our time installing things, configuring them, trying to tweak them, trying to work out, yeah, okay, some of us like that, trying to figure out exactly how to use it, and not getting the effect that you should get from a new tool, which is that it makes your life easier. And as a developer of a tool, you should have used it enough that you have a good sense of where the balance is, what to optimize for, what will make it run in the generally nicest sense, so a default. But yeah, bad defaults cause issues. And what is a bad default? Well, speaking quite broadly, oh yeah, I forgot to say my other disclaimer. Most of this, well, yeah, all of this, I guess, touches on things that people get very opinionated about. And I'm going to tell you my opinions. If you are a developer on one of the pieces of software I'm going to talk about, I apologize for thrusting you in the spotlight. And if you think I'm completely wrong about something, do come up and tell me afterwards. I probably won't be taking questions now, but if you come find me at the coffee break, then we can talk about it. It'd be great. So a bad default, I would say broadly, a bad default is something that can lead your users to suffer from data loss, security breaches, or in the worst case, that their device or computer becomes part of a botnet. Because, I mean, I said this is the worst case because if you're part of a botnet, you've already suffered data loss and security breaches. And now you're like hacking Facebook for Ukrainians or something. and causing more people to suffer the same problems. Okay, let's get into some examples, just so I can really say what I'm thinking about with some specifics. And I'm going to start with something that's really close to home for me, because this is something that affected me at work. It was a quiet day in December 2014, and I was working at Leap with a group who were making an open data platform for a client. And we were using CKAN, which is a really well-known framework for making open data platforms. So if you know the UK government's open data website, where you can download all these different data sets, that's based on CKAN. And so is the American open data website, American government's. So it was a quiet day, December 2014. Suddenly we got a really panicked email from our client, because he had gone onto the website we were building for him, and he saw this: hacked by Slayer's hack team. Slayer's hack team, that sounds even worse than a regular hacking, right? So he panicked, he called us, we panicked. And then we quickly figured out what was actually going on, because it had been on the CKAN developers email list for a short while, and we just sort of actually read our emails and, oh, right, that's what happened. It wasn't a real hack, as you would call it. No one had gotten into our database. But what had happened was that at this time, the CKAN default security settings would allow any user to come onto a website built with CKAN, and whether or not they were signed in or whether or not they belonged to an existing organization, they could create a new organization and upload new data sets. And there was a group, or maybe just one person in their bedroom, I don't know, who were going around uploading stuff to lots of CKAN-based websites, scaring people, making them think they had been hacked. And as for why this happened, I found the pull request where these default settings were changed. And I hope you can all read this at the back. I'll read it out in a sec if you can't. I found this great comment from David Reed, one of the core CKAN developers, that I think really explained it. This is a hangover from the original vision of CKAN being open editing like Wikipedia. But apart from datahub.io, I don't know of any instances that don't want it to be only edited by officials. So it sounds like a good plan to have these defaulting to false. And yeah, this was exactly the case for our website. Our client belonged to a government department in Switzerland, and they only wanted official government data sets to be uploaded to the website. So we changed these settings to false in our instance. We felt kind of bad. They got changed in default CKAN, and so far as I know, this hasn't happened new since, although it was quite easy to just Google hacked by Slayer's hack team and find websites that still had this up from nearly 3 years ago. Possibly it is a problem. I'm just going to stay on here because I can see someone taking a picture. Cool. Okay, so this was closer to home and it was fairly small. The open data world, it's not that big in comparison to the real world. Like the real world, the whole internet world. We think we're real. So now I'm going to move up, way up in the scale. In 2015, the amount of data in MongoDB databases that was accessible publicly with no authentication was 595 terabytes. That is a lot of data. And just in case you thought this was a problem only a few years ago, this is a blog post from the official MongoDB company blog from last month, September 2017. Warning of a new wave of ransomware attacks. Reports have emerged of a new wave of ransomware attackers searching for misconfigured and unmaintained instances of MongoDB. We have been monitoring the situation closely to help investigate and provide assistance. So this is still an ongoing problem. And as you can probably guess, this too is an issue caused by bad defaults. Up until 2.6, version 2.6 of MongoDB, which came out in April 2014. By default, MongoDB databases were not bound to localhost. You could access them from any server. When I say bound to localhost, I mean that if you have a program which talks to a MongoDB database, that means that they're both running on the same server, essentially, and only your program can talk to it. And then your program acts as kind of gatekeeper for who can get what in and out of the database, which is how it should work. And even worse, originally in the default settings of MongoDB, authentication was not required. So if you have an older MongoDB-based application, good, no one is running out of the room, so I think we're probably okay. But yeah, that would be the correct response. So yeah, in the last few years, lots of databases have been hacked, ransomed, or just wiped, or even worse, they tell you they will give you back your data when you've paid the ransom, and they wipe it anyway. So yeah, as I say, localhost only binding became default in 2.6.0 and in packaged releases. And that will be the case in MongoDB Server directly from 3.6, which is the next upcoming release. I'm not sure when that's coming out, but I guess it should be soon. But as we can see, lots of people either don't have the inclination or don't have the capability. Maybe if a product was passed on between team members to, or passed on from a technical team to a non-technical team, don't have the ability to go back and change the settings on all of these databases. And so the problem persists. There have been some other cases, quite famous cases, of insecure access to data stores, caches, databases, which I won't go into detail because they're quite similar. It's affected Hadoop, it's affected Redis, and there's a really weird exploit possible with Elasticsearch, also based on previous insecure default settings, which I encourage you to go to this website and read about because I won't do it justice in the space of one slide. Yeah. So that's MongoDB, and they, in my opinion, they reacted really way too slow to this. They've known about the problem for years. The localhost binding is only now, like this year now, coming into the core defaults. And I believe they probably started out with this insecurity just because it's easier to get it set up. When you set up your database, you don't have to worry about, first of all, configuring authentication and binding it to different servers, because when you start a new project, that was quite Freudian. When you start a new project, everything is in flux. Okay, so everyone knows, nobody knows anything that everybody knows. You may not be surprised to hear that MongoDB has had problems in the past with insecure defaults. So you may think it's out there. So I'm going to now come back into core Python, the Python standard library. And this is a quote that I really liked from the document of PEP 476. The S in HTTPS stands for secure. And if you are connecting, making an HTTPS connection to another server, you would expect it to be secure. And when using standard library HTTP modules like OLib, OLib2, HTTP, HTTP remote, you would expect HTTPS connections to be secure. But up until PEP 476, which was proposed in August 2014 and then accepted in October 2014, this wasn't actually the case. When making an HTTPS connection, the code would wrap it in a would accept the connection and get the certificate, the X509 certificate from the other server, and then it would just say, yeah, that looks fine. Just like, oh yeah, that's good. And connect. And you, as the developer, are like, neat, secure connection. When module was not actually checking that the certificate was signed by any certificate authority, it could have been self-signed. In some cases that's okay, but we just didn't know. And it also wasn't checking that the common name of the certificate matched the common name of the server. So it's like, right, I need a passport. Oh, right, Bob Jones's passport. That's great, in you go, Frank. And yeah, the API calls looked very simple, but they were insecure. And lots of people actually who did know about this switched to using the requests library instead, which in my opinion is simpler to use, but yeah, if you want to use standard library for some reason, you should be able to do that confidently. I even saw one person saying, when people ask me why I switched to Go, it's because their HTTPS connections are secure by default, which seems like a really exaggerated response to me, but hey, it's important, right? So, yeah, in PEP 476, proposed and accepted, this was changed to actually examine certificates. Yep, yeah, that's all I had to say about that one. Here's another example, and I just stole this. This comes from a talk by Tom Eastman called Serialization Formats Are Not Toys. And it's a really good talk. I recommend watching it on video, or at least looking through the slides if it's something that interests you. And what I learned from it that I had not known before was that YAML, the serialization format, will allow you to include in a value arbitrary executable code. So the innocuous example that Tom Eastman suggested for this in his talk is you can include some code so that when you import data that's stored as YAML, instead of having just a string formatted date, you can have an actual datetime object. That could be really helpful. Or you could have something like this, which is not helpful to anyone. If you load this YAML with a YAML parser, it will it will call rm star on the current working directory where the parser is running and delete everything, which is probably not something you want to be blindly open to. In Python, one of the most used or known YAML parsing libraries is PyYAML. And I would say the default, the obvious way to load YAML is to call pyaml.load. And this will do exactly what I just said. If your YAML file includes embedded code, then it will run that code and create a datetime object or potentially do something much more scary. And you can imagine that if you're just loading your own configuration and you know it's only you who's ever touched it, this is probably okay. And if you're importing any data from YAML that an outsider or a user could ever potentially have so much as touched, you should really not do this. You should use safeload instead. pyaml.safeload. Now, to be fair, in the tutorial of the documentation of PyYAML, it does say this. It warns you, if you're loading in external data, don't use load, use safeload. But if you're not looking through the tutorial, it's really not obvious. And say you're in one of these situations, you're working on the basis of some example code you found on the internet, we all do it, and this code includes load, you just use load. Or say you're working in an IDE and relying on that to suggest method names. You start typing, right, I want to load, oh, load, great, load.
Good question.
Or, for example, if you're sort of going on the example of things you've used previously, the standard JSON library just uses load to load in data, so obviously PyYAML must do the same. Yeah, and so I feel like this is really dangerous. I feel like load should be safe and loading things unsafely should be unsafe load or something. Yeah. So that's just one thing that could cause some issues, and Tom Eastman's points out a bunch of examples where, in the wild, where it really has caused security holes.
Questions?
Is there anyone in the room who is a developer of MongoDB? Like, no? Okay, good. If there were, you know. I really apologize for bookending my examples with 2 cases from MongoDB. It feels a little mean, but you know, I'm going to tell you about something that's been fixed. They did good. Anyway, MongoDB used to be forgetful. Fire and forgetful. And what I mean by that is, in default, if you tried to write data to your database, it would just ping off a request to the database, write that, and without waiting or checking for any errors, it would go on to the next task, which generally is fine and it's really fast. Mongo is meant to be fast, so this is good. However, if there is an issue, if there's any error with your database, with whatever, with your data, with your drive, with your disk, then you could just lose stuff and lose it forever and just not know. You could just be writing and writing to a full-up notebook or like a stone or something until you went back to try and get your data, you wouldn't know. So in 2.6, again, the weird thing that I noticed when I was preparing for this talk is that loads of my examples have a link to 2014. I guess it was just a very, bad defaulty year. So in 2.6, they fixed this. They changed all of the different, and there were several, write methods in the shell to default to writing, checking for an error, and then going on. And this makes it much more reliable. You don't have to worry about silently losing data anymore. But of course, it did come with performance cost, as they noted in the release notes. Yeah, because checking and waiting is a lot slower than just throwing things out there into a void. Could someone tell me how I'm doing for time? Because I can't actually see anything that tells me the time. I'm doing fine.
Okay, so.
Perfect. That's great. Great, I've got 10 minutes. Okay, so we've looked at a load of horror stories, holes that you can drive your users into by just giving them the wrong default settings. Let's finish up more positively. We want to set up good defaults. And first, I'm just going to review reasons why I think bad defaults get set up in the first place. It can be because the developer knows the tool, they work with it every day, they created it, and so they either configure it always themselves, or they just have a really good feeling for how it should be set up. And so it never really occurs to them that other people will not have this feeling. And that's perfectly normal. Like, that's definitely a human failing, I guess. Another is unconsidered use cases, or as we saw in the case of CCAN, changing use cases. Early users and developers of CCAN wanted to build something that was completely open, anyone could edit it, and later use cases were more focused on institutions or government departments, and they wanted, although they were opening up the data, they wanted their platform to be more locked down. And then there are times when you as the developer or your team as a development team really want to show your tool in its best light. You know that your tool is really performant, it's super fast, so why kind of bog it down with settings that hinder it and slow it down? People won't see it at its best. And you know that your tool is really easy. You know that you can set it up on someone's screen and they will just be able to get in there and start hacking. It's what we like to do. So why hamstring them with telling them, oh, you have to configure this and you have to set up that, okay, now find one last thing, before they can actually get using it and see how fun it is. Other cases are internal tools becoming external. It's kind of another thing of changing use cases. The tool goes from an environment where certain assumptions are default, and everybody knows something about the tool, out into the world where no, people don't realize this. It's not their area of specialty, it's yours. And finally, what I feel may have been the case with PyYAML, though maybe someone can tell me in more detail, improved methods are added later. But by that time, once you've added, for example, I don't know if this was the case, once you've added safe load, you can't call it load because load is already there, taking up the namespace. And so the better, for whatever reason, methods get a lot less discoverable. Discoverability is really important with defaults. Yeah. And in all of these cases, what I really want to stress is that people don't make these mistakes because they're bad developers or because they're stupid or they're mean. They want you to lose access to your device. This is a quote from a paper called Insecure by Default by two researchers, Lee and Evans. And in that paper, they looked at the security status of 5 or 10 of the most popular web development frameworks. I think Rails was in there, I think Django was in there, I don't quite remember all the rest. And this is one of their conclusions. We expect most of the insecure aspects of current web frameworks are not due to ignorance or carelessness on the parts of their designers, but difficult trade-offs between security, functionality, usability, and ease of development. And yeah, it's true, we make those trade-offs every day when we design and build software. I just want you, in your future work, to try and keep a few things more present at the top of your mind when you're setting this stuff up. And so these are my... Oh, one final thing. We're Pythonistas. We should take inspiration from the Zen of Python. 2 points in particular I think are relevant here. One, explicit is better than implicit. And the second one, errors should never pass silently. This was actually cited by Alex Gaynor in the document for PEP 476, where they pointed out that, yes, when the PEP was accepted and certificates were actually checked in the future, yeah, probably connections would break in some software that had been using the standard lib modules. But those connections, that software was already broken. It's just that nobody knew about it. It was supposed to be secure and it was insecure, leaving it open to man-in-the-middle attacks. And that's not the kind of thing you want to create and then just not know about. So finally, here are my recommendations for priorities on default values in your software. I would really love more software to be secure by default. Just, yeah, think about Mongo, think about the 600 terabytes of data out there on the open web, just like a huge honeypot. And I would also really love software to be reliable by default, over being performant. I don't really care how fast your tool is. If it's overwriting my data or if it's losing my data, then I'm not going to use it. And when I find out about that, I'm going to dial it right down anyway. So yeah, please start off this way. If a user has a use case for a really fast piece of software where it doesn't matter that it's not 100% reliable, you can tell them how to adjust that, and they will do it. Yeah, as I just mentioned, never swallow errors, at least log, at least warn. And consider whether it's worth doing a hard fail on serious errors. If your program or my program is writing to a disk that's completely full up, I would really rather not kind of 3 days later scroll through my logs and see, oh yeah, info, disk full, but I've been writing to it because it continued on in this broken state. Think about whether it's better for your software to carry on broken or just die so that it can get fixed. Yeah, if there's no safe defaults, so again thinking about authentication, putting in default user and password for something that can be deployed on the open web is probably not much better than having no authentication required. Because, okay, so I go to a database running this database system and I just put in root, and okay, it's fine, it's open. Yeah. So if there's no safe way to set a default, just tell the user to set it themselves, to configure it. It won't be that much of a hindrance to them. And last of all, if a bad default does happen, be brave enough to fix it, as most of these cases have done. Yeah, you won't be able to go back in time and change the earlier releases of your software. You won't be able to call up every user who's using the previous values and tell them to fix it, but at least fix it for future use cases. That is everything I had to say on the topic. I would like to warmly thank PyCon for inviting me here to speak. It's really exciting for me. I would also like to thank my partner David Stark for a lot of long conversations on this subject, my company, as I mentioned, for giving me the wherewithal to get out here, and finally, everyone who answered my question on Twitter saying, hey, I don't want to miss something, tell me your favorite broken defaults. Oh, and this is something else that surprised me. I, of course, sorted all of their user handles in default source order, just called sorted on a list of them. And the third entry there is something I did not expect to see. Can you read that? I have the capital letters first, and then Tom Christie, who has an underscore at the start of his Twitter handle, and then all of the lowercase letters. Okay, apparently that's a standard. I did not know this. And last of all, thanks ever so much to you all for being a really great, responsive audience. Enjoy PyCon UK.